The title of my talk today is towards the physical basis of consciousness. I'm a neuroscientist by training, and also I do also psychology, and also I use a computational technique to try to understand what consciousness is. And today I'm going to talk about some of my research as well as the latest sort of the theoretical or experimental development of this topic. So before I start my own sort of the experimental work or theoretical thing, I just want to start my own sort of the history, personal history of, as a consciousness researcher. Since I was a kid, if I remember correctly, when my dearest friend died, I started to wonder, like, what was it like before I was actually born? Now that my friend died, where did he go? And also, what would be like in the transition between this kind of thing? And if I remember correctly, probably this was around my 5th year of the life, and that was probably the start of my consciousness research, yeah, in a sense. At that time, my parents or my friend's parents said that he went to he became a star in the sky, and that's a nice story for kids probably. But as a young amateur scientist, I thought that this can't be true, because if that's the case, then there are many stars in the sky, and it should increase as many as I count. But it turns out that after 40 years of my life, I realized that there are many stars in the sky. So it may not be actually in the end a lie. All right. So then after becoming more mature, when I was at junior high school, I had a conversation with my friend who had a doubt that my yellow may be corresponding to your blue or something like that. I don't know if you have also had this kind of conversation with your friends. And then we had a long conversation going back and forth between the station to the school, and we couldn't resolve this particular question. We usually made a lot of progress about this kind of question, but this one particularly, was very difficult. Any kind of solution I come up with, my friend would say, but I can't prove it. How do you know that if I lie or if you lie? It's very complicated. So that was really nagging question. And then also, if you have have a pet like dog or fish or fly or if you raise trees or whatever, you might wonder maybe there is something to be like that. Do you have the same kind of feeling? But it's actually scary to think that many of the throughout the long history of the humanity, especially in Christianity, until at some point, for example, most of the animals except for humans are considered to be not conscious. So dogs or cats do not feel pain, so you can do whatever you like. And until recently, or even in some culture right now, some people think that the children are not conscious. So you can do whatever you want. It's really scary, but this has flagged in the history of the sort of the consciousness research. And then now you have an emerging field of this robot or artificial intelligence, and if it becomes extremely capable, like Siri or whatever, Google AlphaGo, who can beat you in many different kind of the tasks, then what do you think about this robot, whether they are conscious or not? That's a currently big topic in the field. And these are, as I alluded to, called mind-body problem in philosophy. But what it means is eventually it's the relationship between the consciousness and the brain. So that's the mind-body problem I'm interested in since I was a kid. So what is consciousness? In my talk, I'll just define, with a relatively accepted kind of definition. It is everything that you know, feel, and perceive, and they are based on your own conscious experience. And if your brain is now processing something that you are not experiencing, it's all about unconscious. And you might be surprised, but there are many, many things happening in the brain that is not conscious. But also, at the same time, you are also conscious of many things. So there are, continuing battle in the philosophical debate on what the extent of the conscious experience is experienced. Anyway, so then the fundamental question is that relationship between the matter and the mind. And the matter here meaning brain. And the mind is conscious experience. And in the clinical context, people talk about the level of consciousness. It goes from very low, like coma, deep sleep, or anesthesia, to high, awake. And I hope that everybody here is now in a high level of consciousness. But I know that some of you already had alcohol, right? So you can go into the low in 10 minutes. And then, assuming that you are now in the high level of consciousness, then you would have different kinds of contents. Most likely, you are seeing me. So visually, you are seeing me. And before I tell you, probably you didn't have that sensation, but you are also feeling something under the butt. But if you pay attention to it, suddenly, you feel that. And that's sort of the attentional sort of engagement of the conscious experience and so on. And feeling or audition and many things that you are experiencing is all the contents, variable contents of consciousness. Self-consciousness is also part of the contents of consciousness and so on. If we define consciousness in that way, then you might wonder, how can you actually do science with this kind of fuzzy, definition? So that's the sort of the starting time of around 1990s, where people started to develop the neuroimaging, where it allows, which allows you to look at what kind of brain activity is happening when you are doing different kind of activity and thinking and feeling and also so on. And my previous PhD supervisor, Christoph Koff, promoted this particular paradigm called neural correlates of consciousness. Although it is very difficult to start with a theory that explains consciousness or just do the experimental manipulation that manipulates everything, finding the correlates is much easier. So what it means is that, let's say, if you show many different kind of the stimulus, either vision or audition or touch or whatever, and then trying to find the neuron inside the brain that always really reliably correlate and co-vary with whatever you are perceiving, experiencing, that is very, a reliable kind of hint. Okay, so there is some kind of consciousness going on in the brain. That's the sort of the paradigmatic strategy for this neural correlates of consciousness. And that has been going on for over the last roughly like 30 years, and we know a lot about correlates. And now we want to go above correlates to go to the theory. And here comes the critical moment for you. So if you take this and then see it through, and it's always nice to see many audience wearing this. So what you can see here, hopefully, is that through your eye that is going through blue, you are seeing a face here. And then through your red, you see house. Then what happens if you open both of your eyes at the same time? Okay. This is very different kind of experience than what you have in the 3D movie theater, right? You see house and the face at the same time. And initially, probably you see both. But if you observe enough, what happens? Huh? Can somebody shout? Huh? Yeah, alternates. Cycles. Do you see this? So even though stimulus or outside world is constant, your mind or consciousness actually changes. This is very bizarre, but this is called a binocular rivalry phenomenon. And I alluded here, this kind of experiment can be done to monkeys. And then asking monkeys, okay, which one are you seeing right now? And the monkey can report, oh, I'm seeing face or house, face, house. And then you find, surprisingly, if you are really lucky and also very persistent, then you can find a neuron like this, which goes like drrr, 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 every time you say that, oh, I'm seeing face. So that's a really strong kind of the neural correlates of consciousness of the face. And you can also find some different neurons that fires only when you see house. So that's the one big kind of finding in the neural correlates of consciousness. This one is very nice because it dissociates the visual input from your contents of consciousness. All right, now I'll switch the gear and you can take off right now. And then just take a look at this central cross and try not to move your eyes or blink. And then I want you to tell me what happens again. What? Can you believe what you are experiencing? So this is the illusion called motion-induced blindness. Yeah? Oh my gosh. Yes. So what's happening here is that I'm not cheating. If you ask your neighbor if I'm actually deleting it or not. And if you move your eyes, you can make sure that everything stays on the screen. Okay, but if you don't blink, if you don't move your eyes, then some of the dot actually disappears, right? Blue one. And here's a very also strange thing. If you try to attend one of them without moving your eyes, that attended one also disappears much quicker as well. Do you see that? No? Yeah, this actually requires some kind of force training, so you may not be able to experience easily. But anyway, so this is another type of the powerful illusion that dissociates from physical to what's going on inside the brain and what you are experiencing consciously. And then now I also produced some kind of illusion like this, which actually turned out to be very powerful and useful for studying unconsciousness. So again, I want you to take this, and this one works only once, so you don't want to miss this particular moment. It's a big moment, okay? So wear this, and you have to be prepared. Are you ready? Okay, so tell me if you see something interesting, okay? But don't shout this time, just raise the hand, okay? Please, let's go. 3, 2, 1, go. Okay. Okay, so how many of you saw the face from the beginning? Probably not so many, I hope. But okay, if it didn't work, then switch the red and the blue side again. And then now you know that it's there, so just pay attention to there. And then repeat it again, okay? 3, 2, 1, go. Yeah? So it's there, definitely, and it is actually stimulating your eyes and also brain as well. But you're not consciously aware of it. So using this kind of technique, you can come up with lots of interesting kind of experiment. And in fact, many people have done that, like showing the nude picture, or showing the tobacco to the addicts and so on, to use this kind of technique as an assay for your unconscious. So now, if you are a really big fan of Freud, you can either support or reject Freud, using this kind of technique. So using this also, maybe we can actually show a bunch of the neurons inside the brain does respond to these suppressed phases. And people like this heroic scientist called Nikos Logothetis did this type of experiment by moving or inserting the electrodes into the brain in different regions, starting from the area that is very close to the eyes to slightly higher level of V4 or MT, and then finally the neurons that specifically respond to the objects. And then what these people have found over the years, over 10 years, 15 years of the work, is that initially, back of your brain doesn't correlate with your conscious contents, but as you go, far front, especially go to the bottom part of the brain, it starts to correlate with your contents of consciousness. But we don't know still why this is the case. That's the sort of the next question. And we can do this type of experiment right now by clever kind of technique called sort of flickering paradigm. So I'll avoid the details, but my previous PhD student, who is now in Oxford University, Matt Davidson, did this type of experiment in humans. And then you see that when he's showing this blue type of stimulus, you see activity in the brain, back of the brain increases, but once you start to see something red, it goes down. And then if you plot the other reversal from red to the blue, it goes like this. So you can now use this type of the brain imaging technique to read your mind, whether you are actually seeing blue or red based on this type of brain imaging. You don't need to insert an electrode into the brain. Very nice. And you can also see what you're conscious of at the moment. So this type of the experiment is now called a no-report paradigm. To understand your contents of consciousness, we don't need possibly detailed subjective reports. And this is a very important paradigm for the future because consciousness and the report is not the same thing, I would argue. And many people have also started doing this for decades. And one of the very significant findings over the last 10 years is this: whether people are conscious or not, can we tell without any reports? That sounds like a very strange kind of question, but they did it. So what they did is using the fMRI imaging scanner that actually exists in this building. Over there, if you have some person who you don't know whether they're conscious or not, you can put them into the scanner here. And what you ask is to ask them to imagine playing tennis. But you can't move, okay? Just imagining playing tennis. And then another type, you ask them to imagine walking around your home or in a building. Okay? And you can imagine that, my sense of the imagination can completely dissociate these two types of the imagination. And if you're a good imaginator, then you can actually activate different parts of the brain. And that can be actually used as a probe whether you are understanding this instruction. And you can use this as a communication tool between the people who cannot speak or who cannot move, or who is very unclear whether he is conscious or not. And when they did it to one particular vegetative patient, so vegetative patient is by definition unconscious. And when you do anything to him, like asking him to raise a hand or move the eyes or whatever, he doesn't respond. So all the clinical criteria says that he's unconscious, but if your family actually believes that he is definitely conscious, then you put into the scanner and then ask him to imagine or walk, then he can show this. Very similar kind of activity. That means that it's scary kind of thought, but probably some part of the vegetative patients in the world, estimated to be roughly like 10 to 20% of the people are like this. It's locked in, but very conscious. Now I want to talk about so that's the sort of the current status of the neural correlates of consciousness and also clinical studies of consciousness. And then finally, I talk about a little bit abstract, but hopefully interesting kind of idea of theory of consciousness. I talk about the geometry of consciousness. Can you quantify and visualize the shape of consciousness or qualia, feeling? How do we know what other people are actually exactly experiencing, like blue versus yellow argument that I had with my friend? So this is a thought experiment, but it is very realistic. If you are seeing this as red dot, what's happening inside the brain and also what supports your conscious experience of the red is not only seeing red as it is, but also simultaneously you are not seeing other types of color. That is actually very important. And seeing red is simultaneously seeing something that is very close to red, like yellow or purple, and very far from in red. And this structure of the relationship is very, very peculiar for each different types of the qualia. Sound has different kind of relation, color has different relation, and so on. And that is very related to the probably states of the brain. What it means for this type of 4 neurons to be active is only determined with respect to other possible states. So people started to think about not only the actual kind of states, but also possible states to start think about, in a sense, information theory of consciousness. And that's becoming very important in the field. And as I said, this color has this type of ring-like structure, and sound, if you think about it, it's actually a spiral shape. Sound of C is very similar to another sound of C, but very different from F or A. But if you go 1 octave higher, then C sounds similar to C. But it's also simultaneously different. This is very different from color, right? But interestingly, both of them, if you ask a physicist, it's all one-dimensional. But in one case, one dimension becomes ring, and another case, it becomes spiral. And why is that? We don't know, but it must be related to the way the neurons are connected in different types of the, for the different types of qualia, for color or sound. And finally, so based on this type of the information theory, now we are looking into the sort of the structure of shape of information. This is a kind of new type of concept, and my student Angus and the previous my student Doro has been working on consciousness of fly, which sounds a bit strange, but this is in the end what we are visualizing is some kind of shape like this, very complicated, but this can be reconstructed from the activity of the neurons in the flies. You might not believe it, but this very, very tiny Drosophila actually contains more than 100,000 neurons inside their brain. And they can generate this type of a very strong, complicated and causal relationship between the neurons. And what we found with this method is very interesting. If we construct this shape for awake fly and also anesthetized fly, by the way, again, same anesthesia that works for human works also for the flies. And then, they don't move and they don't, walk around. And then again, this anesthetized fly actually crushes this shape smaller. And then this wakeful and active and very nice fly is like gigantic. And this is very, very schematic and also the beginning of the research, but we believe that extending this, we may be able to get to the sort of the theory that predicts based on the possible states of the neurons and also information, you must have this, blue color definitely right now, and you must have, yellow color seeing the same thing. Yes?
Can you clarify what does the geometry represent? Is it different neural stimulations or which neurons are firing?
Yes. Okay. So, all right. Maybe using this figure, I'll explain. So this roughly corresponds to each of the activity representing different areas of the brain. You can imagine that this is a vision activity, audition, emotion, and the feeling or something like that. And then what you see here is the interaction between these different sensory modality. And if you remember how you were in a dreamless sleep, none of these things actually interacts. But when you're awake, all of these sensory information actually interacts and generates this very strong interaction.
What do you mean by interact?
Causal interaction or irreducibility. So in a simple way of explanation, you have this neuron's activity and you have another neuron's activity. And if you can predict what's happening here, just by looking at this alone, then there's no interaction. But if there's something else going on, then it's interaction. It's very good. I can't really answer your question, but anyway. So that level of this higher level interaction, a causal interaction integration is very specific for awake flies. That's what it shows. And a particular shape should predict the contents of consciousness. That's what I'm very interested in pursuing for the next 10 years, 20 years, possibly. All right, so just to sum up, the future research and the speculations. So empirically computing structure of so-called integrated information from real neural data is becoming possible to predict the contents of consciousness, and then we can combine this kind of approach with the existing previous type of the research, as I mentioned in the beginning, right? Neural correlates of consciousness or visual illusions. And if I'm correct, then when I'm showing, when I'm computing your brain's shape of this thing, when you report that, oh, I don't see the blue dot right now, but now I see it. It should be possible to predict it based on this. And also, not only that, if this particular theory is correct, then we should be able to do that across the people as well, even without a report, because this is sort of the physical theory that predicts this contents of consciousness across the people. And not only that, then it also should predict that different species should also have different kind of contents of consciousness, and this theory should predict what kind it is. It's not only like, whether the flies are conscious or not. That's, in a sense, to me, boring. What kind of consciousness they could have? That's the question that I'm interested in. And this, I don't know if you are a philosopher, this question, what it's like to be a bat, this is a philosophical question, previously proposed as an impossible question, but I think this is a way to address it. We can't probably verify it unless I become bat, but at least it's almost similar to the presence or absence of the black hole, right? Black hole, I can't directly test it by myself. When I test it, I die. But based on the theory, we have to just accept that that kind of statement has to be the case. So thank you for your attention on consciousness. Now I take questions.
Thank you very much for a wonderful talk. Does the book Metamorphosis deal with similar questions?
Mm-hmm. Can you say that again?
It's a book, novel called Metamorphosis, where a human turns into an insect and has different experience.
Yeah. Yes.
In the geometric shapes of consciousness,
yes.
What does distance mean? Because you said that the difference between the awake fly and the anesthetized fly was that the anesthetized fly was crushed. And what does that represent? Like, what does the distance, what does being crushed mean? And how does that mean that it's anesthetized?
So, yeah, you are very interested in this concept. I'm very glad. I usually lose the audience with this slide, but okay. So here, the location in this two-dimensional grid doesn't mean much. It shows that 1 unit and 2 units and 3 units and 4 units. So it's just that. And then the height of this structure, information structure here, you see, there is this enigmatic symbol, phi, in Greek letter, that quantifies how much irreducibility you are observing by looking at the two things at the same time compared to one at the same time, separately. So here, what it means is that AB sort of entangles a lot. So AB looked at together, then you have many different things compared to A alone or B alone. And then same goes for ABC or ABCD, these four neurons. So this is a measure of the irreducibility.
Hi, Professor. Thank you so much for the talk. It was really interesting. My question was, so when somebody had asked, do those also represent brain regions?
Uh-huh.
So you had said the points also represent brain regions?
This one?
No, not this one. In the graph itself.
Oh, this one?
Yeah. So do they also represent the spatial orientation of the regions in some way?
Yeah, so that's almost like, forefront of my research. I want to know that answer, actually. But it's very interesting, if you are skeptical about, some of my, statements. One of the statements which is very skeptical is that, I can predict the conscious states across the brain. The reason being that if I'm doing this kind of analysis for different individual, how do I know that my brain, my neuron A corresponds to your neuron A? This is a very difficult kind of problem. And if you are the young scientist who are present here, just come to my lab to address this kind of question. But I think there is a way to deal with it. It's too involved here, but maybe we can talk later.
Professor,
yes.
I want to know whether the unconscious mind has a hysteresis. A little experiment you can do at home. You look at your face in the mirror. And of course, you see your face, but you look at your eyes in the mirror, and then avert your eyes to your left ear. And look at your face and you find your eyes don't move. I don't understand that. I think it must be tied up with some subconscious hysteresis.
Yeah, I guess I probably understand what you mean, but maybe my answer may not be directly related to that. But I don't know if you have experimented by yourself, but go and then stand in front of the mirror tonight or tomorrow morning, and then try to look at your left eye, and then move your eyes to look at your right eye. And I bet that none of you can actually detect the movement of your eyes in the mirror. It's called saccade suppression. So when you are moving your eyes, you don't want to see the blurry image, so your consciousness is kind of edited. Before the eye movement is happening and after the eye movement is happening, it's kind of pasted together and then expanded this, without eye movement parts, and that's what you are experiencing. And as you said, so these kind of experiences are also, very useful tool to understand neural correlates of consciousness, because it turns out that many of the brain regions, almost like all areas in the brain, is significantly modulated in terms of the blink, which also you don't notice much, right? And also eye movement, even though your conscious experience is more or less stays the same. So that also reduces all the possible neural correlates of consciousness. But what I'm trying to get at with this type of analysis is that, by doing computing or, focusing on this irreducibility thing, rather than just a neural activity, we may be able to find something that is consistent regardless of the eye movements or blinks.
Well, with the advances in brain imaging, how realistic it is to read the contents of the brain, especially low consciousness, when someone's in a coma, for example, can you accurately determine what they want to do? Do they want to terminate their life, for example?
Right. So that's also a very, very hot topic right now. And it turns out that this kind of experiment, if you do a super conscious person like you, sometimes it doesn't work. So if you were to use this as a sort of the criterion for death or life, you might be dead now. So it's not the super sensitive kind of method right now, but there are many different kind of proposals going on right now. Like one of the most promising technique right now is to stimulate your brain somewhere, far from the ear or eye or whatever, more closer to the contents of consciousness, and then see how that stimulation propagates to other brain. And that seems to discriminate between whether you're conscious or sleeping or anesthetized and so on, very, very accurately. But still, we can't classify vegetative patient versus a minimally conscious patient with this. So we need more advanced.
I'm just wondering whether or not the approach you're taking generally might in the future be adapted to determine whether or not AI has achieved consciousness.
Right. So I think, in the end, at some point, we need to really deal with this, actually, because it may be the case that, some of your computer is actually conscious, and turning off corresponds to killing, this thing. Maybe not allowed ethically in the end. We don't know right now. Going directly to perfect AI is very difficult right now. But one step before that is so-called neuroprosthetic kind of approach. Many people in the University of Melbourne and also Monash are also doing this type of research, but you basically replace only parts of your brain with artificial device. And right now, when you do that, your conscious experience also changes. But if you can actually generate a device that actually replaces your brain one by one, and your conscious experience doesn't change, then it starts to become believable that completely replacing your entire brain with that particular type of the rule that follows with the brain artificially should replace your consciousness, right? Then after doing that, building from the scratch of this type of artificial consciousness is probably indistinguishable from human consciousness. That's a theory, but we don't know. It's very far from that level right now. And anything that you replace, it's always changing a lot.
So thanks very much for coming. Thanks very much to Now for an excellent talk. And what I'm going to do today is take you on a brief tour of the other side of consciousness. So Now has been talking a lot about waking consciousness, and I'm going to talk about sleep. I'm going to take you on a tour of some of the philosophy of dreaming, of the philosophy of sleep and dreaming, but also of scientific discoveries on sleep and dreaming. And I'm going to try to convince you that recent findings are actually revolutionizing our understanding not just of what sleep is, but also of wakefulness and of consciousness itself. And a question that I'm interested in my research that will keep coming up throughout this talk is quite similar to Now's, but again different. And I'm not asking so much, what is it like to be a robot? What is it like to be in certain states of consciousness? What is it like to be a fly? I'm asking, what is it like to be asleep? And the first thing we need to know in thinking about this is where we're starting out from. So what is sleep, or what do we commonly take sleep to be? And here's a bit of a traditional view. So I'm just going to start out with some dictionary definitions that I think are going to be close to what many people think sleep is. So sleep is a condition of mind and body which typically recurs for several hours every night, in which the nervous system is inactive, the eyes are closed, the postural muscles relaxed, and consciousness is practically suspended. Or, as Webster's tells us, sleep is the periodic and naturally occurring suspension of consciousness during which the powers of the body are restored. So essentially, sleep is a state in which the lights are out, nothing is being experienced, there's no consciousness, and really nothing much is happening. If this were true, it would really be quite a boring state. Sleep is the absence of activity, it's the absence of behavior, and it's the absence of consciousness. And this view, I think, is still very widespread and popular, and it's a very old view, so it dates back all the way to Aristotle, so in the treatises on sleep and dreaming, which were really one of the first attempts to formulate a physiological theory of sleep and dreaming, we have Aristotle telling us that sleep is a period of uniform passivity and rest. So again, it's just a completely uniform, quite boring state in which nothing is happening, and it can be defined as the absence of wakefulness and perception. Wakefulness and sleep are opposite, and sleep can be defined in purely negative terms. And we have that then all the way fast forwarding into the middle of the 20th century to Norman Malcolm. We then see that coming back as a conceptual point. If a person is in any state of consciousness whatsoever, then it logically follows by conceptual necessity that that person is not sound asleep. If you were to say that a person in this view who was sound asleep was having any kind of conscious experience, that would be a conceptual contradiction, much like saying that a triangle has four sides. So that's the traditional view. That's what we have through philosophy, through the history of philosophy. That's what we have through much early theorizing about sleep and dreaming, and that's what reaches into folk psychology today, and that view is almost completely false. So that is basically what my talk is about, to say all of the things, or to show you all of the things that are wrong with that view and that understanding of sleep. Sleep is a lot more interesting, in fact, than this. A first way in which that traditional view is false is that sleep has a very complex architecture. So here's something like a typical night. Here we can see different sleep cycles. So each of these will represent a sleep cycle. And what we have here is then the different stages of non-REM or slow wave sleep. As we drift off to sleep, go into deep sleep. It used to be 4 stages of non-REM sleep that were distinguished. Today it's just 3. And then we go back into REM or rapid eye movement sleep, which might be followed by a brief period of awakening, and then back into non-REM sleep, and so on and so forth throughout the night. Now, each of these sleep cycles, consisting of non-REM plus REM sleep, takes roughly 90 minutes, and what you can see is that throughout the night, the deeper stages of non-REM sleep disappear, and REM periods get longer. So sleep actually has a very complex architecture that is also actively organized and controlled largely by the brainstem. And these sleep stages are distinguished in different ways, so that they're distinguished through differences in heart rate, differences in muscle tone, differences in eye movements that occur. So hence rapid eye movement sleep, characterized by these characteristic rapid eye movements in that sleep phase. But essentially they're also distinguished by different types of brain activity. Here is measured by EEG. So if you just look at the entire brain, electroencephalograph of the entire brain during sleep, we see that in wakefulness we have fast, desynchronized activity that then progressively gets slower as we move into the deeper stages of non-REM sleep. Here, N3 is the deepest stage of so-called slow wave sleep. And then when we go back into REM sleep, rapid eye movement sleep, we see very fast, desynchronized activity that is very different from these slow waves. And the interesting thing is that in REM sleep, brain activity, if you were looking just at EEG from REM sleep, it looks almost the same as what the brain is doing in wakefulness. So in fact, the brain in REM sleep is actually highly active, is in some parts even more active than in wakefulness, and that's extremely surprising, and that's completely different from what the traditional picture of sleep told us what sleep was supposed to be. And then the next interesting thing is, and this was discovered back in the 50s by researchers working in sleep laboratories, is that if you wake people up from REM sleep, they're very likely to report dreams, whereas if you wake them up from the other periods of sleep, they're much less likely to report dreams. And this led to a fascinating idea, and that was that we might have something like not the neural correlates of dreaming and consciousness in sleep, but something like sleep stage correlates of dreaming. So given that dreaming is so much more likely to be reported following REM sleep awakenings than awakenings from REM sleep, early dream researchers assumed, so here's this really groundbreaking paper by Dement and Kleitman from the 50s, that you could actually use the physiological characteristics of REM sleep as an objective marker of the presence and absence of dreaming. So and with this work, you now had the beginning both of a science of sleep and an objective science of dreaming that happened there at the same time. But what interests me here is how these findings changed our conception of sleep. So with this, suddenly a completely new understanding of sleep became necessary. And here we have Michel Jouvet, another pioneer of early dream research, saying that these early discoveries showed that REM sleep is neither sleeping nor waking. It's obviously a third state of the brain, is different from sleep as sleep is from wakefulness. So given these findings, in other words, given the high activity that we're seeing, the wake-like activity in the brain in REM sleep and the correlation with rich subjective experience of dreaming, REM sleep no longer fits into the traditional conception of sleep, right? It has to be something else. And the understanding of sleep itself, sleep proper, thereby gets narrowed to non-REM sleep, which is then equated with unconsciousness, right? So sleep proper is now non-REM sleep, and we can see another trend here that I think is quite interesting, and that is no longer just sleep being defined in negative terms through the absence of behavior, of consciousness, and so on and so forth, but non-REM sleep equated with unconsciousness being defined in negative terms through the absence of REM sleep. So now the thing that is not interesting is non-REM sleep, and indeed much of dream research henceforth focused on REM sleep. And we have quite a similar dichotomy. So here we had the old dichotomy between sleep and wakefulness. It got slightly more complex when we had to deal with a third state of the brain, namely REM sleep dreaming. And then we have a very similar dichotomy happening in consciousness science that is popular to this day, and that is that consciousness itself can be defined contrastively by what disappears every night when we fall into dreamless sleep and reappears when we wake up or dream. And we find this both in philosophy and both in and also in neuroscience, this view. And this is also kind of a first indication of how the study of sleep and fluctuations in consciousness and unconsciousness in sleep can be informative beyond sleep and dream research, namely also to think about various disorders of consciousness, coma, minimally conscious state, and so on and so forth. So the idea being that we have this natural loss of consciousness in sleep, and if we could understand that better, we would thereby also understand what goes wrong in various disorders of consciousness. But again, here the idea then being that we have this clear-cut dichotomy between consciousness, which exists in waking and dreamless sleep being lights out, unconscious. And again, that story is compelling, but it's also too simple. So now we're going to make the story even more complex. And that is, firstly, that we should not be led to identify from those early findings, as attractive as that would have been, REM sleep and dreaming and non-REM sleep and unconscious dreamless sleep. Because in fact, many studies have shown that dreaming occurs not just in REM sleep, but also in all of the stages of non-REM sleep, including the very deepest stages of non-REM sleep. And you also can get REM phases without dreaming. So there, in fact, is a double dissociation between dreaming and REM sleep. Just one study here to illustrate that point, that actually non-REM sleep is a lot more interesting than anybody ever thought in terms of consciousness versus unconsciousness. And this is some work from the Tononi lab by Francesca Siclari, using something called serial awakening paradigms, which just involve waking people up at very short time intervals, something like every 15 to 20 minutes throughout the night in a sleep laboratory. And if you do that throughout the night, including from non-REM sleep, you actually get rich reports of conscious experience happening even in the deepest stages of sleep. So here you have N3, so deep sleep, and you can see up here there's still a fairly large proportion of reports of conscious experience happening, even more so in N2. Then you've got a fairly large proportion of no conscious experiences, so people saying that they had actually lost consciousness. And then there's kind of an intermediate block of reports where people are saying they had something called white dreams, so they felt they had experiences, but they can't report any more details. And it's quite interesting to think about what might be going on in these so-called white dreams, these types of experiences without any particular recall. For now, what interests me about this is that this shows that non-REM sleep itself is phenomenologically rich. We have consciousness, we have a loss of consciousness, we possibly have different types of consciousness occurring even in deep sleep, even in non-REM sleep. And that means that the original project of having something like sleep stage correlates of dreaming versus non-dreaming doesn't work. You cannot use sleep stages conventionally defined to diagnose the presence versus absence of consciousness. What this then means is that as a next step, we actually need a new way to think about what dreaming and dreamless sleep is supposed to be. And that's where a lot of my work as a philosopher comes in. So recently, after much disagreement in dream research as to what to say about dreaming, as to how to define dreaming, there's now been convergence on so-called simulation theories with different people from different researchers from different fields agreeing that dreaming is at heart here and now experience. Dreaming is at heart immersive. It's very much like a virtual reality experience. You have the experience of a virtual world and that virtual world has a self at its center. And the self that you experience in your dreams, you, is typically doing quite different things from the self that is actually, or from your actual body. You're lying asleep in bed. None of that typically plays a role in your dreams. You're moving through this rich dream world. You might not even dream of being yourself. You might dream of being a different person or a different version of yourself or even an animal. So it's in a way the ultimate virtual reality experience that you're having in your dreams. But all dreams tend to have this immersive here and now self in a world structure. Now, simulation theories can focus on different aspects of dreaming. There's some very interesting work looking at social interactions in dreams. So one thing that I find quite fascinating is that you have even more social imagery in your dreams than in wakefulness. So if you ask people how many social interactions they have, and if you compare that with dream reports, they're actually having more social interactions in their dreams than in waking. And another thing you can do, and that's something that I've been quite interested in, is look at in more detail how the dream self is represented. So do we have a dream self that is able to think similarly to waking? Do we have the same memories in dreams that we have in waking? Do we have the same autobiographies? Do we have the same bodily experiences that we have in wakefulness, given that all of this is largely happening independently of input from the sleeping body? And finally, what is the simplest way of experiencing oneself as a self in one's dreams? Is there somehow a minimal kind of self-experience that could still persist in one's dreams and that could help us get a handle on self-consciousness and variations in self-consciousness? So that's a brief overview of simulation theories of dreaming. And I think they help us make progress on these questions on the relation between dreaming and sleep stages, because this is a way of defining dreaming that looks at the structure of dream experience, but it defines dreaming independently of sleep stages. So it's quite open to saying that dreaming could be occurring outside of REM sleep as well. And that seems to be exactly the type of definition we need to move forward. It's also a definition that can lead us to an interesting further question, and that is, does consciousness really disappear in dreamless sleep? Does it even make sense to ask about that? Well, if we've defined dreaming as immersive here and now experience, we can suddenly say what dreamless sleep experience could look like. And that is an experience that still, it's something like to have that experience. It's something there's something it's like to be in that state. But that experience would no longer have the immersive structure, the here and now structure, the structure of a self in a world that characterizes both dreams and wakefulness. And if that were the case, if that's the kind of conceptual framework that you're working towards, then you could say, well, does consciousness disappear in dreamless sleep? Well, sometimes yes and sometimes no. There could be cases in which that immersive structure is lacking, but something is still being experienced. So one example would be sleep thinking. Some of you might have had that experience if you have an important thing you have to do the next day. You have to wake up and go on a trip, or you have an important talk you need to do, or a job interview or something like that. You might have the feeling that you didn't sleep at all, but that you were just thinking the same thought throughout the night. Am I going to wake up in time? Did I pack my suitcase? And so on and so forth. Now, those sleep thoughts are typically just repetitive and non-progressive, and they often do not have the rich kind of imagery that dreaming has. So that would be a kind of non-immersive sleep experience. It would be experience in sleep that does not count as dreamful. But there might also be something else. So I've been interested in this, as have several other philosophers working in Canada and also in Germany. So could there be something like minimal phenomenal experiences, the simplest way of having any kind of conscious experience whatsoever that persists even in deep dreamless sleep? Now, by definition, because we've defined dreaming as here and now experiences, these would have to be experiences that lack the structure. There would no longer be any particular kind of imagery. You wouldn't be hearing anything. You wouldn't be seeing anything. There would be no bodily experiences. And you would even no longer have the experience of being or having a self. So the self-other distinction, the distinction between self and non-self, would have disappeared. But maybe still some kind of experience could be continuing. And if we had something like that, we might be approaching an understanding of the minimal conditions for conscious experience to occur. Again, if we had that, we could then also apply that to disorders of consciousness, for instance, in coma. Now, here's what I think could be an example of something like that. So a dream report, in this case from a lucid dreamer. So she writes, I'm suspended in space, in dream space, I think. There is nothing here, just millions of grayish dots. And I am one of the dots. There is no dream body anymore. I'm just a dot of pure consciousness suspended. A feeling of great peace comes over me and a sense of gentle, infinite expansion. It's as if everything and nothing are the same thing, and there is a sense of effortless belonging. And I think at that point, something really interesting is happening, right? At the point where the dreamer says, I'm just a dot, I don't have a body, at that point, the dreamer is still has something like a self, still has something that I would call a minimal self. There is still a sense of here versus there. There is still a basic kind of self-other distinction. So by my lights, that counts as a state that still involves, that still could be immersive and dreamful. But then everything expands, and that sense of identification, even just with a dot, without bodily experience, even that goes away. There's no longer a single dot of consciousness. All the dots are me, and I am them. There's no I and them. We are one. There's a blissful sense of timelessness and oneness, and after an indefinable length of time, I wake up, and I start feeling my body again in bed. So what I would say is that here we have a transition between a minimal kind of dreaming involving here and now experience and the loss of that, but we still have a continuation of experience even after this experience of being a self, of being a dot has disappeared. There's still a sense of timelessness. And aside from that, there's really not that much to say about that intermediate period. And I think that's exactly as it should be. If we had these minimal phenomenal experiences, this minimal kind of consciousness involving no imagery, no self, no particular kind of content, there would be nothing more to say about that. There would be an indefinable moment of time, and after that one would wake up. But one would have had the feeling that in the intermediate period, one wasn't quite unconscious, the lights were still a little bit on, and then one returned. So that's the idea that here we have a transition from dreamful to dreamless sleep experience, and that might help us get a handle on different types of experience and how they relate to changes in the sleeping brain. So one way to move forward from here is to say that we do want to pursue the old project of finding sleep stage correlates of consciousness versus loss of consciousness, of dreaming versus dreamless sleep experience in sleep. And one way to do that might be to aim towards more finer-grained sleep stage scoring. So this was the picture I showed you at the beginning with conventionally defined sleep stages, and what we might try then is to identify smaller, more precise, more fine-grained sleep stages within these conventional definitions. Sleep onset seems to be a wonderful example of how that might go. So here's some work from the 90s showing that within this short period, so basically drowsy wakefulness reaching through N1, so sleep onset, into very early N2, so typically just no more than a few minutes, you can distinguish 9 different EEG substages, right? So you can have a much more fine-grained scoring system with different EEG waves, and these different substages characterizing basically our transition from wakefulness into sleep. And then the next step would be to align these changes in EEG substages during sleep onset with changes in experience. And exactly that seems to be possible during sleep onset as well. So during sleep onset, many people experience what is called hypnagogic imagery. And this seems to go in a particular progression. So it often starts out as unimodal, very short, snapshot-like imagery, seeing a face coming out of nowhere, hearing voices, having the feeling of floating. But it's not really the surround, immersive, VR type of experience that we have in dreams. So it's more like seeing something on a screen than being there in a virtual reality. Whereas in the later stages of sleep onset, and again, we're just talking about several minutes here, you often have something like short dreamlets or microdreams, right? So suddenly there is the feeling, wow, I was standing on some steps and there were candies falling down and I was able to kick them. And then you wake up. So often there are these kind of very short but yet dynamic narratively organized episodes that suddenly do involve something like a self relative to an immersive environment. So again, here we would have a transition from something like non-immersive to immersive imagery. So one way to move forward would be to have more fine-grained sleep stage scoring and align these finer-grained sleep stages with distinctions between different kinds of conscious experiences. And the way of doing that I'm offering is through their immersive structure, but there might also be different ways. But I want to end with something more revolutionary and something more, much more interesting in a way. And that is the question, maybe by having more fine-grained sleep stages, we're looking for differences within the sleeping brain in all the wrong places. Because it could be, or everything I've said so far has been assuming that the whole brain is changing its activity as we move from waking through the stages of sleep into REM sleep and back. But the interesting thing that is coming out of sleep science is that in fact the changes could be local. It could be parts of the brain that are changing their activity, and possibly those local changes could be determining changes in conscious experience as well. So there's some evidence from this on learning tasks. So if you have certain learning tasks that change activity in wakefulness in a certain closely circumscribed area of the brain, you will also see heightened slow wave activity in that part of the brain when people sleep afterwards in the lab, and that will in turn be correlated with an improvement in performance. And these types of experiments are leading sleep researchers, including people like Thomas Andrian working here at the MBI, to increasingly say that sleep is not a whole organism or even a whole brain phenomenon. Increasingly, researchers are saying it's parts of the brain that are sleeping, and neuronal assemblies, not the entire brain, are the fundamental level to look to. So you can have differences within non-REM sleep and slow wave activity. Some parts of the brain can be more deeply asleep than others. You can have slow wave activity, which is characteristic again of non-REM sleep, occurring in REM sleep, and you can even have it in wakefulness. So you can even have parts of the brain that are functionally asleep in wakefulness, whereas you would never be able to tell that from the outside, just from the behavior of the person. The behavior of the person would seem awake, or maybe not. Maybe they're briefly mind wandering or lapsing in attention. So the question would then be, and that's to wrap up, can we use these local changes in brain activity and align them with changes in experience? Maybe. So some new work is indicating that maybe, just maybe, in non-REM sleep, the difference between dreaming and non-dreaming is exactly a kind of local change. And maybe what needs to change in the brain is not a flip from non-REM to REM sleep, but maybe just activity in something like a hot zone. And maybe it's the same local areas that need to be activated in a certain way independently of conventionally defined sleep stages to bring about dreaming versus non-dreaming. Another way in which that might happen is lucid dreaming. So again, just very briefly, how many people here know about lucid dreaming? Okay, very good. So dreaming that you're aware that you're dreaming while you're dreaming, often have some level of dream control. It's a real phenomenon. It sounds very odd, but there's very good scientific evidence supporting that it is robust. Here we have evidence that is older from Stephen LaBerge, one of the pioneers of lucid dream research, using a lucid dreamer in a laboratory and asking that dreamer to signal after they had become lucid that they were now having a lucid dream. How can you do that? You can do that by directing your eye movements within the dream. So if you realize that you're dreaming, you can look right, left, right, left. Those eye movements will correspond to your real eye, sleeping eye movements, and can then be read out on the EOG. And there is some newer work then from Ursula Voss, for instance, suggesting that what happens when the brain shifts from non-lucid to lucid dreaming again is going to be a local change. It's going to be a change in the frontal areas, more activity, more wake-like activity in the frontal areas, which are associated with critical thinking and memory and control and so on, that marks the difference between non-lucid dreaming and lucid dreaming sleep. So again, that might be a local rather than a whole brain difference. So I think all of this taken together really puts pressure on how we think about sleep staging, but also about sleep more generally in states of consciousness. So suddenly questions like who or what is actually awake, who or what is actually sleeping, is it the whole person, is it parts of the person, is it parts of the brain, suddenly become really hard to answer. And I think to make sense of these things, we're really going to have to shake and change our understanding and our use of these everyday concepts and ask these seemingly weird questions to make sense of the science. And what we might also have to do then is think about local states of consciousness. Does it make sense to think like that? And how would we move forward? So I'm going to end with that question. And also, just to wrap up, remind you how far we've moved away from that traditional conception of sleep. So we started out with the traditional conception of sleep, which was pretty boring. Sleep is a period of uniform passivity and rest. It's the opposite of wakefulness and sharply distinguished from waking. It's a thing the whole brain does as it switches gears into different kinds of activity. And with the exception of dreams, it's uniformly unconscious. And what we have ended up with is something with a complex architecture that is actively orchestrated, something that is gradually continuous with and often shades into wakefulness, as we saw in local sleep during waking, and also something that could be phenomenologically quite rich and might even have a greater variety of different types of experiences than in waking. So with that, I thank you for your attention. I hope you've been able to stay awake throughout the talk, and I'm happy to take some questions.
I was wondering if anyone has looked at using some of these techniques on non-humans, because they have different methods of going about sleep. So the first thing that comes to mind is dolphins, where traditionally we've described them as half the brain going down at a time. Has anyone done any of this kind of work with other animals?
So what you're alluding to is unihemispherical sleep, right? So dolphins, and that was one of the slides that I didn't have time to go into and kind of put at the end of the talk just in case, so this is great. So there's, so dolphins, like you were saying, basically one half of the brain, one hemisphere can be asleep while the other is awake. And I think they do really fascinating stuff with us. So even if they're swimming in a group, the one that swims on the outside, they will flip their sleeping and waking hemispheres to kind of align with their swimming position. I'm not sure we can quite do that, but there's something called the first night effect. It's a problem for sleep researchers because people sleeping in labs typically don't tend to sleep the way they sleep at home. But it's also something we all know. For instance, if you spend the first night in a hotel, you're not going to sleep as well as you did at home. And you will feel that you were kind of half awake throughout the night. And this study looked at this kind of first night effect and related it to this idea of differences in sleep depth in the different hemispheres. And what they found is that, in fact, one hemisphere in the first night of sleeping in a new environment was going to process auditory stimuli and more deeply than the other hemisphere. So it was almost, they said it was almost like a night watch effect. It was almost as if half of the brain was a little bit awake and monitoring the external environment. And I think that fits extremely well with the subjective experience of the first night effect of kind of not having slept completely, which it turns out we're not doing. So what they didn't do, to my knowledge, was really look at the subjective experience associated with that, but that's exactly what I would be interested in as a next step. Yeah, so thanks for that.
What about time perception during sleep and dreams? So obviously, like, everyone's had that experience where you've been asleep for 15 minutes and you wake up and you feel like you've been asleep for hours. So,
yeah, that's a really fascinating one, and it's a really, really tough one. So there has been basically a whole range of theories to look at this. So there have been some arguments both from kind of 19th century dream researchers, and also Daniel Dennett had something like this on dreaming that he wrote back in the 70s, was the idea that dreams might not just have, like you were saying, a different sense of duration, but maybe we have this experience of having temporally extended dreams, but in reality, they're taking up no time at all, right? So the thought experiment that Daniel Dennett had is even more radical in the sense that it says, well, maybe dreaming is just instantaneous. And at the moment of awakening, you basically hallucinate a memory of a temporally extended dream. So just to say, the theories here have been wildly diverging in terms of whether dreams have any temporal extension at all. Lucid dream research does suggest that they do have a duration. But beyond that, it's really hard to say. And my hunch would be that there's just a huge degree of variation there. So one thing that I can say, there's been some work with lucid dreamers asking them to signal when they were doing certain types of activities in their dreams. So for instance, how long does it take to take 10 steps in a lucid dream as compared to waking, or how long does it take to go through a gymnastics routine? So this was work by Michael Schredel and Daniel Erlacher in Germany, and they found that it takes roughly a similar time as it does in waking. It might take a little bit longer in your lucid dream, probably because you're concentrating on doing these weird body movements that, and you don't really have the physical feedback from your sleeping body to do it. So that's one thing. There also seem to be in non-REM sleep some cases of static dreams where people say that they felt nothing much was happening at all. So maybe they were just sitting on a bench and watching something, but nothing was happening. So kind of a feeling of some sense of duration, but not really being able to say how long, and nothing much is going on. So I think that is quite interesting as well. My hunch would be that even when dreaming disappears, even when you have dreamless sleep, there is still some sense of the passage of time. We rarely wake up and have the feeling that we didn't sleep at all, that there was no intermittent period. But I think essentially this is an extremely interesting thing, and we need to look more at that. Yeah.
My question was, it concerns meditation and the various forms of meditation, and I'm wondering whether you found any correlation between the different stages of sleeping and different meditative states, or is this another phenomena altogether, different phenomena?
Not at all. So this whole idea of dreamless sleep experience and minimal phenomenal experience in sleep really was inspired in part by work with meditation and reports of meditators being able to witness non-lucid dreamless sleep. So Evan Thompson has a really wonderful article and book called Waking Dreaming Being, where he looks at different, firstly at Buddhist philosophy, and also at meditation science and cognitive science, and how they all come together. And he has a wonderful chapter where he reconstructs a debate in Indian philosophy about whether we remain conscious throughout dreamless sleep, which in turn then inspired the work that we did together on do we remain conscious throughout dreamless sleep. So that's very much coming from there. And in those traditions, there were different schools and different ideas, but one school had the idea that you do indeed, or it is indeed possible to witness dreamless sleep and to have the experience of remaining conscious and having some form of witnessing and insight even after all kinds of imagery and all kinds of thought contents and dreams have disappeared. So maybe that's something like lucid dreamless sleep, and maybe that's close to what I was showing you with the dot reports, but I have not researched that personally, but I think that's a really fascinating phenomenon. Yeah.
There are some that say that being in a comatose state is almost being in an eternal dream. So how then would we, I guess, differentiate being in a comatose state to being in a sleep state in terms of consciousness?
That's a really good one, and I don't think I can answer that. So one hope that I would have, and I kind of alluded to that at a few points in the talk, is that we can use sleep and the different stages of sleep and the waxing and waning of consciousness in sleep and all of these different forms of conscious experience to understand better what is happening in the brain and what is changing in the brain to bring about these changes between non-conscious and minimally conscious and richer forms of conscious experience. And maybe if we could do that, we could then also use that to better understand these disorders of consciousness. But yeah, beyond that, I can't.
Can I answer?
Yeah. That's great. I was hoping for that.
From a neuroscientific point of view, coma is very different from vegetative state or minimally conscious states. Yeah, the activity level goes really, low, and it's very difficult to imagine if any kind of, of the dreaming will be happening at that low level of the activity. So, that's a small point, but maybe it's good to understand.
I have a question about sleep and shift workers, because I've been a shift worker in the past. And shift workers have a raw deal where sleep is concerned, especially if it's rotating shifts. There's constantly being in sleep deficit, being jet lagged, almost.
So I think there is, for the local sleep work, there is evidence that, for instance, if you have sleep deprivation, which would also include these kinds of shifts and jet lag, you might have increased instances of local sleep and wakefulness. So these cases of parts of the brain basically sleeping or having sleep-like activity when you're awake. I don't know of any studies that have systematically looked at that with dreaming, though they may exist. Yeah, so that's what I would say to that. Thank you.
Thank our partners. Also like to thank Professor Gary Egan, Lisa Hutton and a team from Monash Biomedical Imaging for making this venue possible.